In this video, we'll carry out an optimal remote-controlled switch placement analysis. This function is part of the Reliability Analysis module. Its purpose is to optimize the placement of a fixed number or optimal number of remote-controlled switches per feeder or backbone according to a selected objective function, such as the minimization of energy not supplied. The optimal RCS placement study case should be active. To start with, we'll carry out a backbone calculation to determine the main backbones associated with the feeders in the network. Backbones are the main paths between adjacent feeders connected via open points that can be used to restore lost load in the event of a fault inside a feeder. The command is found in the Distribution Network Analysis toolbox. The calculation is executed for all feeders and is based on network structure. The backbone objects can be seen in a Network Model Manager. Now we can return to the Optimal Power Restoration toolbox, where the optimal RCS placement command is found. On the Basic Options page, the For All Feeders option is selected, and the objective function is set to minimize ENS, or energy not supplied. We've set the number of new remote-controlled switches per feeder or backbone to 1. This option is used to specify how the calculation results should be saved. On the Advanced Options page, we can see that RCS placement is set to 4 selected backbones separately. So a separate network variation will be created for each backbone in order to save the changed network state, that is, the new RCS. We execute the command. You can see the results of the calculation in the output window. One new RCS has been created for each backbone of each feeder. In the project overview, we can see that a folder of network variations has been created. Each variation has a single expansion stage containing the new RCS placement. Remembering that this calculation was carried out in order to minimize ENS, or energy not supplied, let's look at one case and see how ENS has been reduced. To do this, we'll go to the Reliability Analysis toolbox and run 2 reliability assessments, one with the initial network state and one with a selected variation activated. The command is already prepared, so can just be executed. A system summary report is generated using this icon. Here we can see that the total ENS is about 216.3 megawatt-hours per annum. Now let's activate this variation. The backbone is located here in the network. The reliability assessment is run again. And the report is generated. We can see how ENS has been reduced by about 0.8% by the introduction of an extra remote-controlled switch.